By the end of this lesson, you'll be able to describe the difference between static and kinetic friction and solve problems that incorporate the coefficient of friction. All right, so let's talk about friction. So let's say you have a box on a surface just sitting there. How much friction is acting on that right now? 0. Everybody okay with that? It's at rest, staying at rest. There's no horizontal forces. Now, if I come up to this and I start pushing on it with 5 newtons, let's say, and it stays at rest, how much friction is there? There would need to be 5 newtons so that the sum of the forces is equal to 0. Does that make sense? It's at rest, staying at rest. Okay. So if we were to zoom in into this interaction between the box and the ground at a microscopic level, right, like doing Google Earth, but like microscopic, you've got the surface of the box and you've got the surface of the floor. Do you see where friction comes from? Okay, it's the interlockings between the mountaintops and the valleys. As you push on this, this is resisting slipping and sliding. Does that make sense? Okay, so if I go and I push harder, say I push with 10, what happens to the friction? And it still doesn't move. The box doesn't move. It increases to 10 as well. You right with that? So as you push harder and harder and harder, friction also increases. Okay? What type of friction do we call this? Static friction. Okay? Pushing harder and harder and harder. Okay. Can this continue to happen indefinitely? Will this happen forever? At some point, you will break the molecular bonds. You'll break these mountaintops. Does that make sense? This is what is known as maximum static friction. Okay, this is your breakaway point. Okay, your maximum static friction. You know you've attained maximum static friction in a story problem when it says something about it's just about to start sliding, or it's just beginning to start, it's just slipped, or what is the maximum angle that this can happen, or what is the minimum amount of force that you would need to, something that like says we're reaching a limit. That screams, hey, maximum static friction is probably going to be incorporated. Does that make sense? Okay, so you're looking for those context clues in story problems like, oh, okay. And this is what's equal to that equation. That point there, not this, just the peak. Okay. Now, once you've broken free, then it's like, okay, you are now in what type of friction? Kinetic. Okay. You are causing catastrophic destruction at a molecular level. Okay. As you push and you're breaking mountaintops off. If you listen, you can hear the little screams of all the little villagers as you decimate their landscape. Okay, this is what causes your tennis shoes to wear down over time. You're leaving mountaintops on the ground. This is why you have to change your tires over time. Does that make sense? Okay, you're wearing that away. I drew it a little bumpy because relatively it's constant, but you hit different landscape features. Like sometimes you're going through the plains, sometimes you're going through the Himalayas. You don't know. Like it's kind of, that makes sense. Okay, but relatively it's constant. Good with that. So that's kind of the deep dive on friction, where that comes from, and all that stuff. Have a conversation. Correct answer is. Correct answer is B. A would be correct if it says has the potential to exert more force. But you don't want it exerting more force than what you're pushing. Otherwise, it's going to accelerate backwards. Boy, you better push that hard, because if you don't, it's going to get you. Okay? It's not going to happen. Okay? It has the potential to exert more, but only exerts as hard as you are pushing to make the sum of the forces equal to 0. You okay with that? Okay. Tell your neighbor. Correct answer is C. Okay. So a couple different reasons. Number one, your inertia now is in motion. It wants to stay in motion. The other reason is, remember on the graph how it dropped a little bit? That is due to the fact that you are, well, it's in static friction. These mountain and valleys are interlocking. And once you break free, you're now just skipping across the mountain tops. Like, that makes sense? Okay. Tell your neighbor.
Even that I'm reading into this entirely. Subway? It reads out.
Like thinking about the questions.
Yeah.
It feels like
What is it? What? Do you think it's media?
I think it.
Correct answer is? Correct answer is C. Kinetic friction is only dependent upon the roughness of the surface and the normal force. It is not dependent upon how fast you're sliding. Okay. Good with that? Okay. If you are not note type people, I'd say take notes. A 75 kilogram baseball player running from home base or running to home base makes a diving slide. Coefficient of kinetic friction is 0.5. What is his acceleration? Now, before you start asking yourself, I wonder what equation I should use, or before you start grabbing your calculator, what do you think I'm going to tell you to do? Set it up. Do so. I'll give you a minute head start. Beat me to the end. What type of friction is it? Kinetic friction. Is there any force going to the right? Sorry, to the left? No. And not unless he's swimming on the ground. Okay. What's enabling him to move to the left? It's inertia. This is put in motion. Okay. He did exert applied force when he jumped, but after he jumped, it's just his inertia carrying him. So that's your free body diagram. I'm going to make to the left positive X, up positive Y. I need you to finish this out. Give you 30 seconds. Set up. Do the rest of the setup. How do we do? Okay. Notice we have not touched any numbers. Not touched your calculator. We've done the setup. Now, what is it that the question is asking for? What are we ultimately trying to solve for? Acceleration. Where do we find acceleration in our setup? Right here. Do I have mass? Yes, 75 kilograms. Nice. Do I have kinetic friction? 0.5? Why not? What is 0.5? That's your coefficient. Watch that, okay? 90% of the time, if I give you coefficient, you are going to be using, this equation. Okay, in this case, it's going to be kinetic friction. Okay, so now I've got 0.5 here, normal force. Do I have normal force? Where can I find normal force? Aha. Do I have force of gravity? Not yet, right? This isn't 75, right? How do I find force of gravity? I use force of gravity is equal to mass times 9.8. So I have 75 kilograms times 9.8 equals 735. 735. Okay. Follow that. Then I can take that and I can plug it in here. So normal force is also equal to 735. Question. Does normal force always equal force of gravity? No. It does in this case, but not always. What then can I do with my normal force? Okay. Oh, crazy, right? So you have kinetic friction is equal to 0.5 is the coefficient times 735. So kinetic friction is equal to 367.5. And then I can do what with that? So I got a negative 367.5 is equal to 75 kilograms times acceleration. Acceleration is equal to negative 4.9 meters per second squared. Okay. There are a lot of little steps. The footprint of this problem is rather substantial, but the steps in that are not that complicated. There's just many of them. It is imperative that you set up your problem and that you keep your work organized. This is actually a pretty basic problem. Okay, but do you see the strategy? Start with the setup. Use your setup as a roadmap. I'm looking for this. I need to find this and this. I've got that. I don't have that. How could I find that? Well, I've got 0.5. Oh, that's this. Oh, but I need normal force. Where do I find normal force? Oh, it's over here. Oh, but that's, shoot. Okay. We can do that. Boom, boom, boom. There, which leads us to here to get the answer. Lots of little steps. Lots of steps. Okay? Keep it organized and you'll be fine. Go ahead.
All those little equations be like at the top of the paper.
Oh, yeah.
Okay.
Yep.
That's my biggest thing.
Nope, you won't have to remember this. Okay, good with that? Okay, here's a harder problem. Trying to push a 100-kilogram couch up a ramp at 20 degrees. What is the minimum force that you need to push to make the couch start moving if the coefficient of static friction is 0.4 and the coefficient of kinetic friction is 0.3? What do you think I'm going to tell you to do first? Set it up. Go. I'll give you a minute. What type of friction is it? Static. And is it maximum? Have we reached maximum? If we were asked to find the minimum force that you need to push it, there's a limit we're approaching. That screams, that's your clue. Hey, we need maximum static friction. Okay. I'm going to tilt my axis because I'm on an incline. So I'm going to make up the ramp positive x and perpendicular to the ramp positive y. This angle here is 20 degrees. I got an FGY. I've got an FGX. Keep going with the setup. How'd we do? Have we touched numbers yet? No. I want you to do the same thing. Do not pick up your calculator. Do not look at what equation should I use until you've done this. Okay, please. This is going to get very involved. You need a game plan. Okay. Thumbs up when you're good to go. Okay. What is it that we're looking for ultimately in this problem? We are looking for the minimum force that you need to push. We're looking for applied force. This is what we're going for. So if we can figure out this and this, we're good to go. Does that make sense? Okay. So force of gravity in the x direction. 100. I can put that in here, right? No. Oh, I can put 100 right here, right? What is 100? Your mass. How do I get force of gravity? How do I get weight out of mass? Use this equation. Force of gravity is equal to mass times 9.8. So I have force of gravity is equal to 100 kilograms times 9.8. So force of gravity is 980. Oh, I can put 980 right here, right? Nope, that's force of gravity. How do I get FGX? I'm looking for the opposite side of the angle, so I'm going to use sine 20 is equal to FGX over 980. So FGX is equal to 355, is that right? What is it? 330.
335.
Okay, 335. Okay, so now I've got that. Now I need my maximum static friction. 0.4, right? Stick 0.4. That's your coefficient. So coefficient coefficient is coefficient of static friction times normal force. Okay. All right, I've got the coefficient 0.4 times normal force. I don't have that. Where do I find normal force? Okay. Are you serious? How do I find FGY? I need cosine of 20 is equal to FGY over 980. FGY is equal to 921. So sticking that over here, find that normal force is also equal to 921. What can I do with that? Okay. So I have maximum static friction is equal to 0.4 times 921. So my maximum static friction is equal to 368. What do I do with that? Okay. So applied force is equal to 368 plus 355. Applied force is equal to 703 newtons. Okay. Lots of little steps. Each step isn't complicated, but there are many of them. They're all over the place. Please set up the problem. Please be organized. If you are faithful with the setup and you're organized, these are not mentally taxing, they're just laborious. Does that make sense? Well, if you can keep it organized, you're good to go. Okay? Got a worksheet due on Tuesday over this stuff. You know how to do it all.